Second law of thermodynamics. It is possible to think of many processes which satisfy the first law of thermodynamics, yet are never observed. For example, consider a book lying on a table. If the table were to cool spontaneously, internal energy of the table would be released as mechanical energy of the book, causing it to jump to a height. This, however, never happens, even though the process mentioned is perfectly logical according to the first law of thermodynamics. Thus, there has to be an additional law in nature which prevents such incidents from happening. This basic principle is known as the second law of thermodynamics. The second law of thermodynamics imposes restrictions on the processes allowed by the first law. In layman's terms, it states that the efficiency of a heat engine can never be 1, and the coefficient of performance of a refrigerator can never be infinite, or that the external work can never be 0. The second law of thermodynamics has two different statements. According to the Kelvin-Planck statement, no process is possible whose sole result is the absorption of heat from a reservoir and the complete conversion of the heat into work. The Clausius statement says that no process is possible whose sole result is the transfer of heat from a colder object to a hotter object.